Hey there. Yes, welcome to our class today. And today I decided to record a video for you people. And we are talking about the Mohr Circle. Okay, we've been talking about principal stresses, principal planes, yeah, specifically in an oblique section. So we have done the analysis bit, the analytic method. Now we want to look at the graphical method. And the first one, we are going to talk about the Mohr Circle. Yes, so let's get to it. All right. The Mohr Circle. The Mohr Circle. Yes. So you have to know that the Mohr Circle is a graphical method of representing normal, tangential, and resultant stresses which are subjected in an oblique section. It applies to the following. It will be drawn, the Mohr circle will be drawn in the following cases. Yes. The first case in which it will be drawn is when a body subjected to two mutually perpendicular principal tensile stresses, which are unequal of unequal intensities. The second one is a body subjected to two mutually perpendicular principal stresses which are unequal and unlike. By that I mean one is tensile and the other is compressive. One is tensile and the other is compressive. The other case in which the Mohr circle will be drawn is when a body is subjected to two mutually perpendicular, two mutually perpendicular tensile stresses, accompanied with a simple shear stress. With a simple shear stress. These things we have already looked at their analytic methods, and now we want to see their graphical representations. So in this class, we will talk about the first two, a body subjected to two mutually perpendicular principal stresses of unequal intensities, and number two, body subjected to two mutually perpendicular principal stresses that are unequal and unlike. That is, one is tensile and one is compressive. So let's get to it. Since it's graphical, I will expect you to have a ruler. And right now I don't have a protractor, but it will be helpful for you. You need to have a protractor. You also need to have a pair of compass to be able to draw. Because I'm using a digital one, I won't need all those. All right, so let's start with the first one, A. Let me increase the intensity of my pen. All right, let's start with the first one. So we are looking at Mohr circle. Mohr circle when a body is subjected to two mutually perpendicular principal stresses of unequal intensities. Realize that they are like, from our previous class, this will look like this. This will look like this. This one will look like this. This will look like this. This one will look like this. Okay. Then it will have, sorry, we said it's tensile. So we'll have stress 1 and we'll have stress 2. So we are drawing the Mohr circle of a body that has been subjected to such stress. Sorry for that. Subjected to such stress. And we were looking at an oblique section with an angle theta. So how do we draw the Mohr circle of such a body? All right. So let's take a few steps. Let's write down a few steps. So procedure. A. Take any point A and draw. Take any point A and draw a horizontal line through A. Then say take AB. Take AB to be equals to shear 1, stress 1, sorry, and AC to be equals to stress 2 towards the right of A with some suitable scale. Now, B with BC as the diameter, describe a circle. Don't worry, we are going to draw this very soon. Let O be the center of the circle. Let O be the center of the circle. See, now through O, draw a line OE. making an angle 2 theta with OB. D from E, draw ED, perpendicular, draw ED, perpendicular, draw ED perpendicular on AB. The fifth procedure is join AE. Join AE. So join AE. Realize that the data that we have from our question, or from what we are looking at, we already have the stress 1, the stress 2, and we also have the angle that the oblique section makes with the normal. Okay, that we already have that. So with this procedure, let's start. Let's draw the first one. I'll be going through one procedure and then drawing it with you. So procedure number 1 is take a point A and draw a horizontal line through A. Okay, so take any point A. Take any point A. For me, I choose, let me see, I choose this as my point A. Let this be my point A. Then it says, draw a horizontal line through A. So with your ruler, draw a horizontal line through A. Draw a horizontal line through A. I have drawn my horizontal line through A. Then it says take AB is equals to stress 1. So let's have this as our B. Realize that stress 1 is the major stress, and stress 2 is the minor stress. Okay, take AB as stress 1 and AC as stress 2 towards the right of A, towards the right of A. So that's why I started by drawing it on the left, because we are going to go to the right of A. So if this is AB, AB is stress 1. Okay, so let me have another line here to give the dimensioning. AB, this is going to be stress 1. This is going to be stress 1. Very good. Stress 1. Okay, and then talks about AC being stress 2. So I can have my C here. Can have my C here. Sorry. Can have my C here. Can have my C here. So if that is my C, then this will be stress 2, AC. AC will be stress 2. Stress 2. That's the first step. The second step states that with BC as the diameter, describe a circle. Let O be the center of the circle, with BC as your diameter. With BC as your diameter. So BC is the diameter. I want now to describe the circle, meaning if BC is my diameter, then clearly somewhere here will be the radius, or will be the center of that circle. Let me call that center O. Can call that center O. Then it says describe a circle. So let me now draw the circle. I hope it will be. Okay, good. Good, 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 good. All right. All right. So I can just extend something small here. Okay. So this O. So this is O. So just to bring logic to the diagram, I can clearly see that the center will be here. It will be here. All right. So the next step is let O be the center of the circle. Now through O, draw a line OE, making the angle 2 theta. So if you had your theta, let's say your theta was 30 degrees. So with your protractor, you make an angle of 2 theta from O with a reference line OB. So because I think I can't do that here. So I'll just use my eyes and say that one will be an angle of 60 degrees of 2 theta. Okay? And say that will be an angle of 2 theta. All right. All right. The next thing that you'll need to do, making an angle 2 theta with OB. Then it says, the next step is from E, draw ED perpendicular on AB. Draw ED perpendicular on AB. Perpendicular on AB. So, draw a line OE. First of all, you have to draw a line OE. So this means this will be E. This will be E. Very good, very good, very good. I hope you're getting this. So it says, now through O, draw a line O, making an angle 2 theta with OB. From E, draw ED perpendicular on AB. So you need to drop a perpendicular line from E to this line AB. So it will be something like this. Very good. You have dropped that perpendicular line, and you can name this one D. Name that D. Very good, very good, very good. What's the next step? Let's see. Join AE. Join AE. Let's now join AE. Join AE. I have joined AE. I have joined AE. So that's the second last step. So that's the second last step. Now the normal stresses. So let me note something here. The normal and tangential. And tangential stresses. The normal and tangential stresses on the oblique section are given by AD and AE. Sorry, AD are given by AD and ED respectively. Are given by AD and ED respectively. You can also join ECE to show you the angle theta. So this will be the angle theta that you are given from the oblique section. This will be the angle theta CE. Very good. So we have the length of AD. The length of AD will be your normal stress. Normal stress on oblique plane. The length of ED will be your tangential stress. Tangential stress on oblique plane. You'll also have the length AE will be your resultant. That will be your resultant stress. That will be a resultant stress on oblique section. Oblique plane. Very good, very good, very good, very good, very good. When you have that, we can now, with the knowledge that you already have, let's try to see if it's true. If this Mohr circle is going to give us the results that we already had in our analytic methods. So let's prove. Let's prove. Let's prove. So the radius of the Mohr circle, the radius of the Mohr circle is CO or OC or OB or OE. CO, C to O, O to B, or O to C, right? Yeah, so the radius of the circle OC is equals to OB is equals to OE is equals to the radius of the Mohr circle. That's the radius of the Mohr circle. From analysis, how will you obtain this radius? If this is stress 1, if this is stress 1, this is stress 2, then it means the diameter will be stress 1 minus stress 2. The diameter of this circle will be stress 1 minus stress 2. So we can say that the radius will therefore be stress 1 minus stress 2, and because we want the radius, it will be divided by 2. Divided by 2. Now, if you want to obtain, OA, how will you obtain OA or AO? AO will be obtained by AO, which will be AC plus CO. It will be AC plus CO. So let's do that. It will be AC plus CO. Very good. What's your AC? Your AC is stress 2. So this will be stress 2 plus, what's your CO? Your CO is the radius of the Mohr circle. CO, radius CO. So CO, and we have the radius as stress 1 minus stress 2 divided by 2. Mathematically, that can be expressed as 2 stress 2 plus stress 1 minus stress 2 over 2, because you just want to bring it as now one family. That will also be equals to 2 stress 2 minus stress 2 will be stress 2. So it will be stress 1 plus stress 2 over 2. Okay? That will be stress 1 plus stress 2 over 2. What about OD? We want to prove all this length AD, length ED, and length AE if they will give us the same formulas that we obtained through the equations, through the analytic equations. So what about the length OD? What about the length OD? The length OD, for us to obtain the length OD, and we already have the radius. We have the radius. Remember, we already have the radius. We will equate it using trigonometric equations. Using trigonometric equations, you can pause and remind yourself how trigonometric equations are obtained. Yes, you can now unpause. So, using the Socator rule, you will find that now we want to express, we have 2 theta, so this will be we want to obtain the adjacent, and we have the hypotenuse, so that will be cos. It will be cos of 2 theta will be the adjacent OD divided by the hypotenuse, which is the radius OE. Ndio, the radius OE. All right, so OD will be OE cos of 2 theta, which will be OE, which will be stress 1 minus stress 2 over 2. We are now picking it here, over 2 cos 2 theta, cos of 2 theta. Very good, very good, very good. What about AD? What about AD? Let's just have them all here. What about AD? AD. Realize that now AD is the normal stress on the oblique section. So if we obtain the normal stress on the oblique section and compare it with what we had from the analytic section, from the analytic method, we can know if this method of the Mohr circle is truly legit, isn't it? Yes. So the length AD will be given by the length AD will be given by AO plus OD, because we already have AO. We have AO here, then we have OD here. So it will be the length AO plus OD. AO plus OD. So that will be AO is stress 1 plus stress 2 over 2 plus stress 1 minus stress 2 over 2 cos 2 theta. So kindly confirm if that's what you had, and that's your normal stress on the oblique section. This is now the normal stress. Sorry. It's now the normal stress. This pen is it's not that good. This is now the normal stress on the oblique plane. Very good. Now we now need to obtain ED. The length ED. How will you obtain ED? How will you obtain ED? We can obtain ED by using trigonometric equations. Since we have the radius, we also have OD, remember? We can express ED by use of trigonometric equations. If we have the radius and we have 2 theta, it means we are looking for the opposite. We are looking for the opposite, and we have the hypotenuse. So that will be sine rule. To obtain ED. Want to obtain ED, sine of theta, 1 sine of 2 theta will be opposite. Opposite is ED over OE. ED over OE. Very good. ED over OE. What does that mean? That ED will be OE sine 2 theta. It also goes without saying that since OE is the radius of the circle, ED will be equals to stress 1 minus stress 2 over 2 sine 2 theta. That is the tangential stress on the oblique section. The tangential stress on the oblique section. So I can write this is the tangential stress. You can confirm with what we had on our calculations. Tangential stress on the oblique section, oblique plane. Very good. You can pause the video as you confirm. Okay, you can continue. Now, so we have already obtained. So to obtain the resultant is obtained by AD squared, because it's just the resultant is length of AE. It will be AD squared plus DE squared square root. Okay, AD squared plus ED squared square root. So there are important points. Let's write these important points to note. Important points to note. Important points to note. Okay, so A, normal stress. Normal stress is along the line ACB. Hence, maximum normal stress will be when, point E is at B. Point E is at B. That is when the normal stress, or that will be when the normal stress will be maximum. The normal stress will be maximum. As you can see, when do you think it will be maximum? If we are taking it from here, AE is less than AB. So it means that the normal stress will be maximum when what? When the stress is at AB, just as we have said. That means for that to be so, the theta will have to be 0. Okay, hence the maximum stress will be when point E is at B. Okay, you can also say that and minimum normal stress will be when point E is at C. That is when it will be minimum. So you can say hence maximum stress is stress 1, minimum stress is stress 2. Okay, so B, tangential stress. Here's a formula for tangential stress. Here it is. In our class, we had said that it will be maximum when sine 2 theta is equals to 1. When sine 2 theta is equals to 1. And if sine 2 theta is equals to 1, it means it will be maximum when what? When we are just taking stress 1 minus stress 2 over 2. What about if we analyze it from the graphical perspective? Right, and say tangential stress is a long line, is a long line CB, is a long line CB. A long, sorry for that, is a line which is perpendicular, to line CB. Is a line which is perpendicular to line CB. See, this one, AD, is a longer line which is perpendicular to line CB. Okay, so we can say, sorry, are you people still here? Okay, good. Okay, along line CB. So hence maximum shear stress. Maximum shear stress will be when perpendicular line CB, when perpendicular to line CB is drawn from point O. Is drawn from point O. Let's go back to drawn from point O. Very good. What are we saying? We have this line perpendicular to ED. It will be minimum. We are now looking at this section. When do you think this line ED will be minimum? It will be minimum when it is 0. Right here. If we draw perpendicular to line CB, right here it will be minimum. As we increase, as we move along that curve, the line ED increases. If it could be here, it could be here, it could be lesser. You get to here, it's lesser. It increases until it is now at the radius. That is when it will be maximum. That is when it will be maximum, isn't it? As you continue moving downwards towards the left, it decreases. It means that the maximum value for tangential stress, is the radius of the Mohr circle. Very good, at point O. So you can write and say, therefore, maximum shear stress will be equal to the radius of the Mohr circle. The radius of the Mohr circle. And what was the radius of the Mohr circle? Tangential maximum will be stress 1 minus stress 2 divided by 2. All right. So very good. So our second instance. So our first one, we are now done with the first one. We were saying that a body subjected to mutually perpendicular principal tensile stresses of unequal intensity. What about now two mutually perpendicular? They are unequal and they are unlike. By unlike, it means, you remember the last question which had a negative 100 kilonewtons per meter squared. Now, something like that. So, let me write it here. Very good. So let's have a look at it. We are now looking at a Mohr circle B. Mohr circle subjected. Mohr circle when a body. Sorry, when a body is subjected to two mutually perpendicular principal stresses. Two mutually perpendicular principal stresses, which are unlike. They are unlike and unequal. They are unlike and unequal. That is, one is tensile and another is compressive. One is tensile and another is compressive. One is tensile and another is compressive. Very good, very good, very good, very good. So with the same data that we have let's say the major stress to be the major principal tensile stress. If you feel tired, you can take a break and grab a cup of coffee or something. You should not be tired when you are studying this. Number two, stress 2, let it be the minor principal compressive stress. Minor principal compressive stress. And let data be the angle made. Angle made by the oblique plane. The oblique plane with the axis of minor principal stress. The axis of minor principal stress. So what's the procedure for that? So what are we saying? We are saying that it will be something like this. Into shape, something like this. Right. Looking at something like this. Something like that. And that has major principal tensile stress. And this is stress 1, which is tensile, and minor principal compressive stress. Minor principal compressive stress. We are looking at something like that. Very good. Very good, very good, very good. Now, procedure. What's the procedure? Procedure Let's write take A, take any point A, take any point A and draw a horizontal line. Draw a horizontal line. A horizontal line through A on both sides. That's the difference in the first one. The first one was on the right side. This is on both sides of A. Take AB is equals to stress 1, which is positive. So let that one be towards the right. To the right of A. And then AC be the stress 2, the minus stress is negative towards the left, the left of A, towards the left of A, to some suitable scale. B, we are saying with O as the center. With O, okay, sorry. Bisect BC at O, sorry. Bisect BC at O. Then C with O as the center. With O as the center and radius. And the radius equal to CO or OB. Draw a circle. Draw a circle. Draw a circle. Okay. D through O, draw a line OE, making an angle to theta with OB. E from E, draw ED perpendicular. Draw ED perpendicular to AB. F, join AE and CE. Join AE and CE. So, very good. Let's do that. Have your ruler. Okay. Let me add a new slide. Quad. Very good. So, the first procedure is take any point A. And draw a horizontal line through A on both sides. So I won't draw it on the extreme, you draw it on near the middle. So your ruler, let me use this kind of pen. Very good. Draw a line. Take any point A. Take any point A. I take my point A here. It says draw a line horizontal line through A on both sides of A. Take AB to be the negative, the positive. So B, I take this as my B. Towards the right of A, and AC to be negative towards the left of A. C, be negative towards the left of A. So allow me to reduce the size, because the diameter of this should be BC, and I don't think this would be logical for us to have a circle that's that big. So let me reduce the scaling. So let's have our A, our B, our C. We have said this is the negative, this is the positive. Okay, this is a stress 1, which is tensile. This is the stress 2, or the minor stress, which is compressive. Very good. Now, bisect BC at O. If I bisect BC, let me use my ruler. This is 8.6 centimeters. So that will be 4.3, which is somewhere here. 4.3 is here, right here. Okay, 4.3 is here. We bisect BC at O. So this is now O. Very good. With O as the center and radius C or OB, draw a circle. So I'll now draw a circle. I'll draw a circle. Sorry. Now draw a circle. Good. That's my circle. Okay. This is B. Okay. The next one, it says through O, draw a line OE making an angle of 2 theta with OB. Through O, draw a line OE. Through O, draw a line OE, make an angle of 2 theta. So if you're usually given the angle. So if you're given 30, then you draw 60 degrees. So I'll draw my 60 degrees to be somewhere here, or my 2 theta. 2 theta. Very good. Then from E, draw ED perpendicular to AD. So this is draw line OE. So this is E. Then it says from E, draw a line perpendicular. So I draw a perpendicular line from this section. Use a protractor, or you know how to draw lines. That is class 4 work. All right, so let's call this draw ED perpendicular to AB. So this to be D. Let me put it here. That's D. Okay. Then The next thing is join AE and CE. Join AE and CE. So it will be this AE and CE. Join AE and CE. This will be your theta. This will be your angle of obliquity. Very good, very good. With that, we are concluding by saying that now length AD, the length AD is the normal stress. Normal stress on the oblique plane. On the oblique plane. Also saying that length, this is AD, length, the length ED is the shear stress on oblique, shear stress on oblique plane. Have length AE, AD, you have AD, ED, AE will now be the resultant. Resultant stress on oblique plane. My charger. On oblique plane. Very good. On oblique plane. That's the angle be the angle of obliquity, which is always obtained as tan angle is equals to tan opposite, which is ED divided by AD. Very good. Let's obtain some equations. Starting with the radius. What's the radius of the Mohr circle? The radius is OB or OC or OE. Radius OB is equals to OC is equals to OE, which is equals to the radius of the Mohr circle. So with that, what does that mean? That means that for you to obtain the radius, you will add AC, because we had AC, which is the stress, the minor stress, plus major stress, which is AB, divided by 2. So, which is also given by stress 1 plus stress 2 over 2. We obtain that by saying, let me give it in bracket form. We obtained it by AC plus AB over 2. AC plus AB over 2. AC plus AB over 2. Now, what about, because we want at long last to obtain AD, ED, and AE, we now have OC. So the next one is to find OA, right? Want to find OA. OA will be the radius minus stress 2. The radius minus the minor stress, or OC minus AC. So to obtain AO, will be OC minus AC, which is equals to, we have OC here, which is stress 1 plus stress 2 over 2 minus, what's our AC? Our AC is stress 2, or the minus stress. So we can also, this can also be interpreted as stress 1 plus stress 2 minus 2 stress 2 over 2, which can be given by stress 1 minus stress 2 over 2. You now have your AO. You now have your AO. You have your AO and you have your AC. You have your AO, you have your AC, so you have your CO. What's the next thing to find? We need to find AD. We need to find AD. AD will be found by AO plus OD. AO plus OD. AO plus OD. AC, AD will be found by AO plus OD. So we'll say AD will be given by AO plus OD. We have our AO, our OD. Since we have the radius, we can obtain it through trigonometric equations. Through trigonometric equation, that will be AO is stress 1 minus stress 2 over 2 plus OD, which will be, we want the adjacent and we have the hypotenuse, it will be cos. That will be a cos. So OD will be OE cos theta plus OE cos of theta. What is your OE? It is the radius. We have it here. So it will be stress 1 minus stress 2 over 2 plus stress 1 plus stress 2 over 2 cos 2 theta. We are looking at this angle, cos 2 theta. Very good. So you have your AD. We said the length AD is the normal stress on the oblique section. On the oblique section. Length ED. Length ED. How will you obtain ED? ED. ED will be obtained through trigonometric expressions too. Now it will be a sine rule. So it will be, we have the hypotenuse and you're looking at the opposite. So it will be, ED will be OE sine 2 theta. Will be OE sine of 2 theta. What is our OE? Our OE is the radius of the circle. And we have the radius here. So it will be stress 1 plus stress 2 over 2 sine of 2 theta. Sine of 2 theta. Very good, very good. What else do you need to obtain? The resultant, we have you already know how to obtain the resultant. Resultant AE. Resultant AE will be obtained by AD squared plus ED squared to the root. Very good, very good. So with that, you can now represent any equation. You can now obtain the resultant, you can now obtain the tangential stress, you can now obtain the normal stress on an oblique section. An oblique section using the Mohr circle. So as part of your assignment, you can attempt further studies. further studies attempt example. Which example is this? Example. Let me see. Example 3.23. 3.23. Which one else? 3.24. 3.24. 3.24. Yeah, that's good. That's good. At reference book is on page 130 and 131 of R.K. Bansal. Sorry, Strength of Materials by Dr. R.K. Bansal. So attempt those questions, and also the third one will now be your assignment. Go and this will be your assignment. That will be your assignment. Express. Use the Mohr circle. Use the Mohr circle to express stroke calculate the normal stress, shear stress, and resultant stress, on an oblique section with two mutually perpendicular. Let me see. With two mutually perpendicular principal tensile stresses accompanied by a simple shear. Also, all assignments will be submitted on or before in a week's time. When will that be? When is today? 22nd, 29th. On or before 29th of June 2024. Email submitted to this email. Email to be sent to the class rep. So that is that. See you next time. It has been great. Hold on. So with that, we can now conclude our class. Yeah, I'll see you next time. Bye-bye.